Hello, everybody. I'm Spandana, and in this session, we will be covering various solutions of blockchain, components of blockchain, and a smart contract which is related to the fund transfer. So, this is the team Shekhar, Charan, Preetham, Shrestha, Spandana, Monica, and Harshvardhan. I will be covering the topic of various solutions of blockchain. So, before going to the topic, let us understand what is a blockchain. A blockchain is a distributed, decentralized, and a tamper proof network which works on consensus protocol. Consensus protocol is like an agreement where all the nodes or all the stakeholders come to a decision of either making a transaction or not. It is a distributed, decentralized, and a non-tamper proof. This means when a transaction is made, it cannot be changed, that is altered, modified, or deleted. Once it is made, and it is the same ledger is being shared to everyone, that is all the stakeholders who are participating. So, blockchain solutions. Before going to blockchain solutions, there are two main things that we need to understand: traditional databases and blockchain databases. Traditional databases, it uses client server network architecture, that is, user is a client and server is the central authority. Here, the system is a centralized system in traditional databases. So the control of system, that is the control of the whole database, remains in a single authority, near a single authority. And if a transaction is made by any of the nodes, it is a responsibility of that particular like a central authority to update it in the ledger, and the access may or may not be provided to everyone. And here, the only point is it can be tampered, that is it can be altered, deleted, or the data can be modified. So the overall security of traditional databases is less when compared to blockchain databases. Let us now understand what is blockchain databases. Blockchain databases is peer-to-peer network. That is, even if you make one transaction in one of the, like a node makes one transaction, it is updated to all the other nodes immediately without any modification. And here, in the security is very high because it follows a consensus protocol where two-thirds of the majority of all the nodes should participate and agree to the transaction. So it is difficult to tamper with, and any modifications of the data is not possible. The security is very, very high compared to the traditional databases. Now, let us understand three different types of transaction, which is physical transaction, online transaction, and blockchain transaction. This is a example of physical transaction. We have two people, Joe and Anne. They are trying. Joe is trying to buy a picture from Anne. So the physical transaction is like an in-person transaction. I personally come, give money, and take the item what I'm trying to buy. So here Joe is personally going near Anne, paying $50 and taking the picture. So this is known as physical transaction. But there are drawbacks of physical transaction. If the person is available in two different states, or if there is unavailability of cash. So at that point of time, we go to traditional online transaction. In online transaction, we use a mediator. The mediator is either a bank or a finance app or any mode through which we can pay the amount. So here, the mediator takes certain amount of incentive. Incentive is like a fee which is used, which is given to the bank. So fee which is given to the bank. So in this, as we can see, Joe is paying $50 plus $1 as the fee, that is $51 to the bank. The $1 is taken by the bank and it returns $50 to Anne. Then Anne sends the picture to Joe. So this is online transaction. The third and the main method, which we are going to focus on, is blockchain transaction. In blockchain transaction, we are going to deal with digital currency. Digital currency is something like cryptocurrency, which is digitally stored, and it's not like the cash available with you. It is all online currency. So here, cryptocurrency is either done with WEI, ethers, and there are many more. So here, if you can see, first, Joe tries to make a transaction of $50 worth cryptocurrency into a blockchain network. In a node, he's trying to generate a transaction, and this is where the transaction is being validated or accepted by the other nodes. And the output, which is, if it is accepted, if the two-third majority of the nodes validate the transaction and tell whether it's authentic or not, at that point of time the transaction is passed, and then the amount is being delivered to Anne. Then, once Anne receives the amount, she will be sending the picture back to Joe. So, this is blockchain transaction. So, in simpler term, traditional transfer is from a person to a bank to the destination. So it's basically like you have an intermediate who takes some amount of fee, who charges you some amount, and then it reaches to the destination. You get the same amount, you pay an extra amount to subsidize your physical transaction, to reduce the drawbacks of physical transaction. Whereas in blockchain transaction there is no need of incentives. In case of like any intermediaries, it directly goes from origin to destination. The only difference here is, if there are more number of nodes participating and you want some kind of prioritization at that point of time, you may provide incentives to the nodes like a fee. That is optional. So, key concepts of blockchain. There are four main key concepts of blockchain. One is peer to peer network, public key cryptography, distributed consensus, and digital trust. So, let us understand what is peer to peer network. As previously discussed, peer to peer network is where all the systems or all the nodes which are connected to each other have equal priority and act as both clients and servers. So here, peer-to-peer network stores multiple copies of the same data. That implies, suppose I have my data in my system, I made a transaction in my system. This the same transaction will be immediately updated in all the systems, and uh, even if there is a loss or my system crashes, I can uh, take the same copy, I can recover or retrieve the copy from other system. So there is no single point of failure, because you have multiple copies present in multiple systems. So, peer-to-peer network is really useful in blockchain network, and it is one of the main features. Public cryptography, which is also known as asymmetric cryptography. In this cryptography, which is also known as DHK, the main use of DHK, which is like discovered by two different mathematicians, Whitefield Diffie and Martin Hellman. So the algorithm comes as Diffie-Hellman algorithm. Key exchange, where two keys are generated, which is known as public key and private key. Public key and private key are used to generate the ciphertext, that is to encrypt and decrypt a message. The public key, both the keys are given by a key distribution center, and the public key will be known to both the sender and receiver. Whereas if the sender is generating the keys, the private key will not be known to the receiver. So, this enables confidentiality and integrity. There is no authentication in this. But in case it is applied in a blockchain network, then authentication will also satisfy. Distributed consensus. As mentioned before, distributed consensus is where all the participants or all the nodes come in an agreement with the central authority. So, in a private network, as it is a central authority and there are no other nodes involved, it is the decision of the owner. Whereas in a public network, where one or more nodes are involved, it is the decision of the nodes, two-third majority of the nodes. If they agree, then a transaction takes place. So if they collectively agree on one thing, that is where a transaction occurs. Either ways, the transaction will fail. Digital trust. Digital trust happens in three ways: generation of public and private key, signing algorithm, verification algorithm. Generation of public and private key, as we discussed, is done by a central, like the main authority, that is a key distribution center, where we can trust the center and see that the keys are confidentially maintained. Then we have a signing algorithm, which is also known as digital signature. Digital signature is a very secure form of signature that provides validity and authentication. And the last part of this is verification algorithm. Verification algorithm is where you're validating the user. You are understanding whether the person who made the transaction and who is like accessing the transaction is the same person. You're authenticating. So here you cover all the three aspects of validity, authentication, confidentiality, and integrity. Because of the digital signature, you can easily understand that the transaction made from one person to the other is securely sent. Components of blockchain will be discussed by Monica.
Components of blockchain. Ledger, node, nonce, hash, and pallet are the components of the blockchain. Node. Node in a blockchain is a device, usually a computer, that participates in the blockchain. So here, in the blockchain, nodes communicate with each other. So nodes helps in validating the transaction and keeping the network secure. There are two types of nodes: full node and a partial node. Full node. Full node maintains the whole copy of the transaction. It has a capacity to validate, accept, or reject a transaction, whereas a partial node has only a limited amount of information, like it only has the hash values, and the whole transaction is accessed using this hash value only. How does a transaction get into a blockchain? So when a transaction is requested, a block is created, and this created block is distributed among the nodes, and these nodes will validate the transaction. So for validating, each node gets a cryptocurrency for its work, and the block is then added to an existing block. And this update is distributed across the network, and then the transaction is said to be complete. So a ledger. Ledger in a blockchain technology is referred to as a digital information which is immutable. Here we are using the word digital because the currency exchange between, we are using the term digital because the currency exchange between the two nodes is a digital, that is a cryptocurrency. And a blockchain is commonly referred to as a public, distributed, decentralized ledger. Types of ledger. There are four types of ledger: public ledger, which is accessible and open to anyone, and anyone can join this network. Private ledger, it only accessible by a selected group of participants or an organization. A permission ledger, so it only allows the authorized participants to validate and access the data. Consortium ledger, it is a type of permission ledger where a multiple organizations collaborate to maintain a blockchain network. And a wallet. So wallet in a blockchain is a cryptocurrency wallet. So which allows the users to manage the different cryptocurrencies. Like cryptocurrency can be a Bitcoin or a Ethereum. So this wallet helps in exchanging the funds and the transactions and making the transaction secure. And it can be accessible from a web or a mobile devices. And here, using the wallet, privacy is maintained. Mainly, wallet consists of two keys: public key and a private key. Public key is just like an email address which is shared with everyone. Private key is like a password which is kept secret with the sender. Types of wallets. Types of wallet. Software wallet. So a software wallet is an application which can be downloaded in the device. The device can be a desktop or a mobile phone, or even it can be a web-based wallet that can be accessed online. This software wallet can be furtherly divided as a desktop wallet, online wallet, and a mobile wallet. Second is the hardware wallet. So these are the type of the cold storage devices, which are typically like a USB that stores the user's private key in a protected hardware devices. These devices are similar to the portable devices that can be connected to a computer, which are plugged in. So this hardware wallet is less prone to malware attacks. So for examples of the hardware wallet are Ledger Nano S, KeepKey are the top hardware wallets used, and a paper wallet. So paper wallet is an offline process for storing the cryptocurrencies. So this wallet is a printed paper that has both your private key and a public key, which are accessed using the QR code. Since these wallets are safe, they are widely used for storing the large amounts of cryptocurrencies. Bitcoin paper wallet and the MyEther wallet are one of the wider used paper wallets. A nonce. A nonce is an abbreviation for number only used one, which is a number added to an encrypted block in a blockchain. So it is usually a 32-bit number, uh, which is randomly generated only once to create a new block or a validated transaction. So these nonce will make the transaction more secure. Whenever you want to determine a nonce, then a trial and error technique has to be used. First, a miner will guess the nonce and it is appended with a current hash header. So after the rehashing, the value is compared with the target hash value. Whenever both are matched, then the miner has created an answer and it is granted the block. A hash function takes a variable length of input and generates a fixed length of output. So here the input string can be a number, alphabet, media files. So the fixed length can vary based on the hash function we are using. If we are using the SHA-126, if you are using SHA-256, then the output will be 256 bits. And the fixed length output is called as a hash. Here, hash has a two unique properties, which is it produces a unique output. It is a one-way function. It means that we can generate the hash code from the input, but we cannot generate the input from the hash code. Example, here the message is given to the hash function, then an equivalent hash is created. A block always contains the data and hash value and hash of a previous block, generating a hash function. So a hash function takes an inputs previous hash function, data block, nonce is given as an input to the hash function, then a new hash value is created.
So now we'll be seeing a smart contract which is based on fund transfer. So for fund transfer, what are the three main functions? Sending the amount, receiving the amount, and getting the balance. So we are implementing those three functions in this particular contract. Initially, if we can see the pragma solidity, this is for the version definition. Here we are showing that our version is greater than 7.2 and less than 9. So either ways, the version, if the current system version is 0.8.21, so if we use this function, even though there is a modification, it still satisfies. That is the reason we are using this function. So, I mean the declaration of pragma version. Contract name is contract ether transfer, which is given to the complete contract. Uh, Function receive ether. Receive ether, as we discussed, is to check whether the sent amount is being received by the other user. Get balance is for getting the balance, like after every transaction we can check what is the balance in the account. View, Why did we why do you think we did used view to get balance? It is because view cannot be edited or modified. It can just be seen or read. So get balance is a non-modified function. It can only be viewed after every transaction. Send ether is for sending the ether, sending some amount from one account to the other. So this is the program. First, let us run it. So now let us deploy. So now the function is being deployed. So as you can see, here we have used the value is 0, initial value is 0. The way in which we are transferring is ether. The account, now when we are starting the transaction, let us consider this account. Ending is 7AB. Okay. So from this, now because it's been deployed, we can see here that there is a deploy function. Now let us click on this. Uh, Send ether. Now we need to take the address of this account. From this account, let's copy and go back to the CB2 account. Send. So we are doing Control V and let us change the value. Let us make it 3. So I'm sending the ether now. The ether send is being successful. Call. Now if you can see, we have received 3 ethers. Now let us get balance. The balance has been updated to 3 ethers. Similarly, we can also send from the other account in the reverse manner. So this is the send and receive. Once we send the ether, I am again sending it, again I'm receiving it. So the value gets updated. Now here again the values become 0. Now on the same account, I will add 5. So my total number of ethers in that account should be 8. Now I send the ether. Okay. I receive ether. 5. Now let us get the balance. Total amount, the total balance amount is 8. Now is this clear? So this is the smart contract which we have executed. It is a simple smart contract for fund transfer and it is really useful. So that is the end of the presentation. Thank you.